Hey guys, welcome to my class Python for Beginners. This is your instructor Amit, and this is chapter number 5 or Conditionals. Today we'll talk about conditionals or the if-else statements I was talking about in one of my previous lectures, and how these conditionals give the programmer a lot of power. But before that, let me tell you about a few other operators. So the first example is of a modulus operator. So modulus operator is nothing but a remainder operator, and I'll just show you by an example what I mean and what does the modulo operator actually do. So let's say you have a quotient of the division of 7 by 3. So now you print the quotient and the quotient is 2, but the remainder of this division, and you know it is 1, you get it using the modulo operator. So it's 7 mod 3, which is print remainder and 1. So our modulo operator can be useful when you want to check the divisibility of a number. Let's say you want to check if the number 64 is divisible by 16. So 64 mod 16, if it is 0, because the remainder of division of 64 by 16 would be 0, and you get a 0. So modulo operator can be used to check the divisibility of a number by another number. Also, it can be useful in the case you want to extract the digits of a number. Let's say you want to extract the last digit of the number 64. So 64 modulo 10 is 4. If you want to extract the last two digits, you can say modulo 100, just 60, and so on. So next topic today is about Boolean values and expressions. So the Python type for storing true and false values is called bool. So the value true, false, these two values are of type bool. So if we say type true is bool, if we say type false, it is also type bool. But these values, remember that these values are case sensitive, so you can't say something like type true. It will say true is undefined. Name error, name true is not defined. So Boolean expression is an expression that evaluates to a Boolean value. So the operator equals compares two values and produces a Boolean value. So if you say the number 3 equals the number 5, which is false, it will say it's false. If you say number 3 equals to 3, this is true. Again, in an expression you can say something like if 64 is divisible by 16, the 64 mod 16 should be equals to 0. This is true. But 65 mod 16 equals to 0, this is false. These are Boolean expressions. So not only the equals sign, there are a few other Boolean operators as well. Something like the not equal to operator, or the greater than, or the less than. So you can have 3 greater than 5, is false. 5 greater than equal to 3, which is true. 5 greater than equal to 5, which is true again. 3 less than equal to 10, that's true, and so on. Again, you can use these as expressions. So let's say you have x equals to 3, and now you say x times 3 is greater than equal to 10. This is false. But x times 3 equal to x times 3 mod 3 is equal to 0. Sorry about that, guys. Okay, that's true. So next we come on to logical operators. So there are three logical operators: the AND, OR, and NOT. Meaning of these operators is similar to their meaning in English. For example, you have, let's say, what x is? X is 3. So if you say that x is 0 and let's say, so the value of x is 3, so x is greater than 0 and x is less than 5. So this thing will evaluate to true because x is 3, x is greater than 0, x is also less than 5. So AND will check if all of the values on which the AND is applied, all of the expressions on which the AND is applied, both evaluate to true. So x is greater than 0 evaluates to true and x less than 5 evaluates to true. So since both of them evaluate to true, the whole expression evaluates to true. So let's say in an expression like x mod 2 equals to 0 or x mod 3 equals to 0. So this quantity will evaluate to true if either of the two quantities is a true. So either x ampersand 2 is 0, which means x is divisible by 2, or x is divisible by 3. If any of them is true, this expression evaluates to true, which is true because x is 3 and x is divisible by 3. Finally, we have the NOT operator, which negates a Boolean expression. So let's say the current value of x is 3. So if we say x greater than 4, is it true? No, this is false. But if you say not x greater than 4, this is a true, because this thing will now check if x is less than equal to 4, which is true. So the NOT of x greater than y is true if x greater than y is false. So NOT of x greater than 4 is true if x greater than 4 is false. So guys, let's just hop on to our next topic now, which is conditional execution. So a conditional execution has the following prototype. Okay. So conditional execution looks something like if Boolean expression. Okay, let's just do it in a script. Makes more sense to do it in a script rather than on the shell. Okay, so the syntax of a conditional expression is something like if followed by a Boolean expression followed by a colon, the indent and statements. So this can be statement 1, statement 2, blah blah blah, and so on. So this set of statements inside the if block is called a block of statements. So as with the function definition from the last class, the if statement consists of a header and a body. The header begins with the keyword if, followed by a Boolean expression, and ends with a colon. The indented statements that follow are called a block. The first unindented statement marks the end of the if block. So statement B marks the end of the if block. A statement block inside a compound statement is called the body of the statement. So this block of statements is called the body of the if block. Each of the statements inside the body are executed in order if the Boolean expression evaluates to true. So, for example, let's say if x is greater than 4, say print x is greater than 4. But we haven't really initialized x. the compiler doesn't know yet, the interpreter doesn't know yet what x is, so it will take some garbage value. Instead we'll provide it with some value. Let's say we want to provide it with the value 3. Now we check if the value of x is greater than 4. So the block of statement inside the if block, which is the print statement in this case, will get executed only if the expression inside of the if evaluates to true. So is x greater than 4 in this case? No, nothing should happen. Let's see what happens. Nothing. But if you say the value of x is 7, now 7 is greater than 4, and now you get something. So here it says that x is unsupported operand types for int and string. So I haven't actually told you how to use the plus operator in this case. So let's say a comma. Okay, in this case we'll use a comma, and 7 is greater than 4. The plus operator, I told you last time, was to concatenate two strings. And so when you say x plus is greater than 4, it will try to concatenate x and the string is greater than 4, but x is not a string, so it throws an error. Say x is greater than 4, 7 is greater than 4. The entire block of the if is skipped if the boolean expression evaluates to a false. Okay. So the next thing is alternative execution. So let's have a function that checks the parity of a value. Parity is if the value is an odd or an even. So we pass it some value x. So we say if x mod 2 is equal to 0, so any number divisible by 2 is an even number, print x is even, then else. So what does else mean? So else follows the if, and it says if the expression inside the if evaluates to a false, then skip the block of if and execute the block of the else. Else print x is odd and let's call this function on some value, check parity of 5, it says 5 is odd, call it on a value 6, it says 6 is even. Okay, so then the condition inside the if must be either true or false. There isn't any third type expression. Exactly one of the alternatives will be executed. So think of it as a branch. So you have a condition x mod 2 equals 0, and you have a branch going to the top and a branch going to down. So if the expression inside the if evaluates to a true, takes the upper branch, else takes the lower branch. Which brings us to another topic, which is our chain conditionals. So sometimes there are more than 2 possibilities and we need more than 2 branches. So Python or mostly all programming languages provide you with the power of having any number of branches. For example, let's say you have x equals to 4 and y equals to 5. Now you say if x is less than y, print x is less than y. elif stands for else if. Elif x greater than y, print x is greater than y. Else let's see what happens here. 4 is less than 5. How the computer comes to this conclusion? Well, so x is 4, y was 5. First it checks if x is less than y, but 4 is less than y, so it says print x is less than y, so it prints 4 is less than 5. Now if we have x5 and y4, then it says 5 is greater than 4, because now it first checks x less than y, which is a false, because 5 is not less than 4. So it now comes to the elif. Elif is else if. So check if x is greater than 4. Well, 5 is greater than 4. So now print 5 is greater than 4. But if both of them were equal, then it says 5 is equal to 5. Because now it checked x less than y, 5 less than 5 is false. Then it checked 5 greater than 5, which is again false. Finally we are not left with any option, so we say 5 is equal to 5. So you can have any number of branches. You can have elif, something else, do something, elif something else. So it's like, you can have any number of branches. Another way to write this is using a nested conditional. So in this case, let's say we have two numbers. First we said if x is equal to y, then print x and y are equal. Else, so the else will always come in the last. Else will always be the last of the conditionals. If you have chain conditionals, else will always be the last, because first you want to check exhaustively about other things, and if nothing matches, then do this. Understand? So first you check if x is equal to y, then print x and y equal. Otherwise, now you can check if x greater than y, print x is greater than y, else print y is greater than x. So now we give it 4 and 5. 5 is greater, 4 is greater. So at the top level, x equal to y is compared. This is not equal, so it branches to the else now. Else block also has a check x greater than y, which is again not true, so it branches to the else following the if. So an else bind the bottommost else here, this else binds to this f, and this else binds to this f. I hope this concept is clear for you guys. It's a little important in the context of learning a programming language. You have to understand how these conditionals work. Another topic for today I want to cover is a return statement. So return statement allows you to terminate the execution of a function before you actually reach the end of the function. So a function that multiplies, a function, let's take example of function that prints the square root. So we call it print square root of a number x. Now square root is defined only for positive numbers. So if x is negative, you want to print that enter only positive numbers, and you want to return. Now You don't actually need an else statement, because once you have entered a negative number, it will return from the function doing nothing else. But if this expression doesn't evaluate to true, if x is greater than 0, then the block of statement inside the if won't be executed, and now you can say result is equal to x raised to the power 0.5 and print the square root of the entered number is x. Sorry, it's result. So let's call this function print square root of 64 and around the square root of the entered number is 8. And if you want to, let's say, have a square root of -1, that says enter only positive numbers. Okay. The return statement can also be used to return the value from a function. So instead of trying to print a value from the function, you can also return the value result. So what does this return keyword do here? It exits the function, no doubt, but the value that follows the result, the value that follows the return statement, is sent back after the function has finished executing. A return statement usually marks the end of a function. The value that follows a return is returned back from where it was called. So now if you said y is equal to print the square root of 64, since you don't have a print statement here because we have commented this out, this won't get executed, so this function doesn't do anything, right? But if you say now print y, so y has been returned the value of print square root, or the value that is returned from print square root has been assigned to y. So now if you try to print y, it is 8.0. This concept we'll cover in a more detailed manner in the next class, but let's get to our last topic of today's class, and that's type conversion. So each Python type comes with a built-in command that attempts to convert values of another type into that type. For example, you have a type 8. Okay, so you say type 8.0, and that's at a type float. If you do 8 int of 8.0, it'll print you out 8. So type of int 8.0 is an int. So the value float that was 8.0 has been converted into an int value now. Let's say x was 8.0, so you say type x, which is float, but now x we say is an int of x now. So x has been converted to the type int using the following statement: int in parentheses you put x. Now if you say type x, oops, sorry about that guys, x is an int. Similarly, you can have a string saying the number 345. This becomes 345 now. But if we said type 345, that was a string, but the int, and in parentheses you put the string, which is a number 565. That, sorry guys, so that now is of a type int. Similarly, int of 1.0 is 1, and on similar lines, a float of 1 is 1.0. Float of 32 is 32.0. We see now that Python distinguishes the value of the integer value 1 and from the floating point value 1.0. So let's see what happens if we try to compare 1 equals to 1.0. It's true because it's the same value, but they're of a different type. Agree? Okay. Similarly, if you want to convert the number into a string, you say string 32 and it prints out string 32 now. So string 34.5. Okay. So last time you learned about concatenation of string, which won't work on an integer and a string. So if you add 34 plus str23, it gave you a type error because int and string cannot be concatenated. But if you say a string 34 plus string hello, that's 34 hello now. Okay. So for Boolean types, the situation is interesting because pool of 1 is true, pool of 0 is false, pool anything, any string is true, pool empty string is false. So Python assigns the Boolean values to values of other types. For numerical types like integers and floating points, 0 values are false and non-zero values are true. For strings, empty strings are false and non-empty strings are true. So with this, I'd like to end our 5th chapter on conditionals, and next time we'll try to build a small program that does something meaningful, and also you'll get the hang of how to write your own programs. So guys, see you around next time. Do take care.